It's Wednesday. We're live. Are we ready? Who knows? Live always likes to throw a few spanners in the works from time to time, but I'm sure we'll deal with it. Welcome back. It's Workshop Wednesday. I believe it's the 4th. If I can get my little finger to pop. It's the 4th stream in the experiment. How is everybody doing? Hope everybody is well. Okay, so tonight we're going to be working on the CNC restoration project that I've got going on. I suppose a little bit of a backstory to the CNC work is probably in order at this point. So a little while back, a very good friend of mine gifted me a CNC machine. I always seem to accrue these machines in a non-working state. That's been true for my laser cutter. It's true for the CNC machine. And I've gone into, for want of a better word, restoration mode. So what we've got is a 600 by 400 CNC machine. It's got a 1500 watt water-cooled spindle, and at the moment it was in a non-functioning state. In fact, I pulled the main controller out of it because it requires a plug-in, which probably costs. It is an expensive piece of software, and I'm gonna get hardware locked into an ecosystem. And I've been burnt with that previously. I've been burnt with that with the laser cutter, in that the software that drives that particular controller is probably late 90s by the look of it, and it's horrible. It is my rite of passage to deal with the software, but it is what it is. Okay, so let's have a look at the machine itself. I've got a photograph of the machine, which we're working on tonight. The actual motion system of the machine is down in my shed, and the electronic side of it is what I'm working on tonight. So let's have a look. So here we've got the machine, and what we're seeing in this shot is first of all, we've got the motion system. So the motion system is right here. This is the water-cooled spindle, and it's got a reasonable size working area. It's pretty dang heavy. It's all aluminium construction, and it's all lead screws for the X, Y, and Z axis. So that means that we can probably put quite a bit of torque down these down the shaft, and hopefully we should be able to work on wood and potentially light aluminium. Just checking something on this side. Okay. Cool. So if there's any questions in chat, by all means ask away. I'm more than happy to go over a few things. We've also got the sub siren in effect. That was quite effective last stream, in that if you subscribe to the channel while I'm live, you will sound off my 3D printed subscription notification. So if you want to take advantage of that, the power to you. Right. Let's go back to that image that we were just talking about. So we've got this this machine, and it comes with a water cooler, and it also comes with this control box. And this control box, it had seen some better days, right? But we're stripping it out. We're building our own CNC controller. This way we will have an open platform to work on. We've done some work on the control box already. It's already had primer, it's had paint, cleaned it all up. I still got to do the lid. The lid needs work, but other than that, we should be good to go. Right, just checking a couple of technical things here for stream. Give me 1 second. And I just realized I've been talking on mute. Well, that's a bit of a dumb thing to do. So recapping, we're working on the CNC machine tonight. The CNC was a gift. It's a restoration project, and ultimately we're putting this back together, trying to get this working in an open source way. We effectively had a closed source controller in here, which the cost of the software is in excess of some of the components that we've got we need to actually purchase for this restoration project to work out. One of those being a VFD, which is a control module for the spindle system, which is essentially the bit that holds the cutter. So what we're going to be doing is we're building a controller from scratch. Now, as I say, we put this 12 volt power supply in a different orientation. It was in a 90-degree orientation for where it is currently putting the terminal block in this location, which meant that it was really difficult to get into these terminals and work on them should you need to. So what I've done is I've designed a bracket and I've rotated this by 90 degrees and screwed it into place. It rises the power supply up because there's actually a bolt holding one of the feet for the case in place. So that rises this up and takes account for that bolt being there, allowing a nice, neat fit. And we also got it so that the airflow for the power supply is right next to a set of fins. I do have this opening here, which I'm probably going to close up at some point with, I don't know, maybe some IO ports or something like that to kind of help us out. With the 24 volt power supply, unfortunately, it was unable to actually change its orientation due to space constraints of where things need to be laid out and all of that stuff. So unfortunately, I've had to keep the 24 volt power supply mounted on its edge, and that does pose a little bit of a challenge when trying to work on the terminals here. It's a little bit tricky to get in there with a terminal screwdriver and actually get this up and running. So, you know, it's not ideal, but once the lid is closed and the machine is running, it's not really going to be that much of a problem. So, on Monday, on my live stream on Twitch, we installed the power supplies and we started wiring things up. And one thing became immediately apparent in that we have an issue with cable routing. It's going to be quite messy if I don't take particular care about it now. We've also got to consider there is a DIY control box coming in here. We're likely to also have a Raspberry Pi in here also. So we shall see. So the plan for this evening is to do a bit of a test. We're going to mock up a 3D object that is going to act as a cable management system to take care of the high and low voltage wires. And we could either make it modular. I'm not really sure how I'm going to approach this just yet. I'm going to figure it out as I go along. There's no real plan as such. So once we get this build underway, that should be pretty cool. But I will be using all of the techniques that I used in the previous live streams, plus I'm going to add a few more into the mix. So fingers crossed you guys find some value in what we're going to talk about this evening. So, shall we get set up? Let's get cracking, shall we? Let's get the control box off the bench, and we're going to start with a productivity hack straight out of the gates. Let's open up Fusion 360, and I'm going to first of all get into my CNC folders, and we'll switch over to the @PC scene. There we go. So you should now get my view of Fusion. And what we're going to do, these are some of the objects that I've made. So here's the PSU cradle for the 12 volt power supply. I'm probably going to delete this PSU bracket for the 24 volt supply because we've now had to rearrange things. This adapter is going to go. The stencils, these stencils I created for I actually used a vinyl cutter to create a stencil to spray paint all of the artwork on the front and rear of the control panel, which is kind of neat because I'm actually using other tools that I've got available here. This is the drive cooler. So this cooler is intended to bolt on top of the stepper motor driver. It will affix the stepper motor driver to the case, and we've actually got a screwless retention system for the fans within the system. And I've got a couple of these kicking about. Where have I put them? Right. So if I go to this shop, so this is that cooler here, or adapter. That's a custom unit designed by me. And we're going to go on now and we're going to create a cable management system to deal with high voltage and low voltage rails coming through the system. So to start with, let's create a new design. And we're going to call this... Cancel that. Don't save. Right, I want to save this file. Okay. And this one, for some reason I've lost audio. But you guys haven't. I see what's happened here. For the lols, right? Okay. So what we're going to do is, let's come over here. We're going to close cable management. And I'm not quite sure how I'm going to do this. So I'm going to observe rule number 1 in Fusion 360, which is to create a segmented component tree within your design. And to do that, we just right-click the root of the design, create a new component, and we're going to call this cable MGMT. That'll do. Okay, so we're going to create a sketch, and we're just setting up our file right now. We're not really doing any significant work. And what we're going to do is we're going to put a construction line right the way through the center of our drawing. And why I'm doing this will become apparent in a moment. So I'm going to just scroll out a minute. And we're going to go from the one, let's go to 200, right? 200 to minus 200. We're going to press X on the keyboard. That's going to give us a construction line constraint in the sketch palette. And we're now going to go here and let's go 400, right? And then once we've done that, we're going to right click it and we're going to fix it in place. So once we fix it, it'll turn green, meaning it's never going to move. So we can use it as some reference material, which you're going to see in a second. So that's the first sketch. Second thing we're going to do now is we're going to productivity hack, right? Would help if I was on the right scene. So what we're going to do is we've put in this construction line, and now we're going to add a canvas. So earlier on, I took a photograph of the control box, and we're going to insert canvas, insert from my computer, and let's go to projects. Documents, CNC, live. All right, so here is our canvas photograph of the control box looking top down. So we'll accept that for a moment. Now, what we probably want to try and do is to orientate the picture with our construction lines so that it's actually, as best we can make it, square. Now, if there are any engineers watching this, you're probably cringing, because ultimately the best thing to do is to take accurate measurements of things and fully define the sketch around this. I'm not going to do that. Not because I'm not capable or don't, I don't want to do that. I want to do it this way so I can show some productivity hacks that will work in a pinch. You're not going to get down to the millimeter accuracy or sub-millimeter accuracy, but it will... I see what's going on here. It will give you... if you work with tolerances, it will give you an acceptable result. Alright, so we're going to rotate this object a little bit, and 5 degrees we can see straight away that's too much. So let's take it down to 2 degrees, and we're looking to square up. Now, what we've also got to remember, because of the distance between the camera and the object, there is going to be a level of perspective. This is just a camera phone. Now, when we get perspective problems, you'll notice that, so this line here is actually parallel to this line here. And what we're seeing here is depth caught in the camera lens. Now, you can overcome this to some extent if you have, say, for example, the ability to optically zoom into something. If you can get far enough away that the lines become almost parallel, you can then zoom in and crush that depth of field. So... Good evening! How you doing? Welcome in, welcome in. Yeah, there's been a few weird oddities going on this evening, but, we just gotta roll with it, I'm afraid. The story of my life, right? So we're gonna change this to 1 degree. Actually, 1 degree looks really good. That looks reasonably perpendicular. I'm just eyeballing things. We're not gonna be working in this lower area, so I'm not really worried if this is not to spec, but it should be good enough. This top line, maybe it is. Let's go 1.2, 1.5. Actually, 0.8, 3.6. Okay, that looks reasonably parallel. Like I say, I'm interested in this area here. Excellent, excellent. Good to see you. Good to see you. Hey, hey. Welcome in, Chris. Welcome back. So we're working on the CNC machine. We are working on building a... cable management system that we're going to 3D print, and we're going to organize all our high voltage and low voltage wiring, try and separate them a little bit, and ultimately try and do a decent job of keeping things separated, making things look nice and neat. So the first productivity hack that we've got here is we've inserted a canvas, and we're going to start modeling shortly against this canvas to give us an object that we can use in our real world example. Okay, I got just crush my YouTube my zoom factor here. I can't read. Ah, yeah. You got my brain working like 1,000,000 miles an hour on that in the conversation in Discord. That's just like... possibilities, man. Possibilities. Okay, so here we go. So we've got our photograph. One real important thing that I had to do was to include something in the image that I can use for size calibration. at the moment, this thing is like teeny tiny, right? Bearing in mind this construction line is 400 millimeters. This thing is tiny. So now we have to calibrate this canvas. So let's go ahead and do that. So we go into our tree and we right click on the canvas. We choose calibrate, and let's now scroll into the image and select 2 points. Now the bigger the area you can measure, the more accurate you're going to be. Unfortunately, I've only got around about 100 millimeters worth of measuring here. See, it only thinks it's 8 mil or 8.5 mil. So let's go 100, and then we can just pull back out of this like so, and there we go. We've now got a scaled image that we can now start to work on. Yeah, I can't wait to see that either. That switch is gonna look pretty dang awesome. Yeah, I couldn't agree more. It is gonna look awesome. Okay. So, I'm gonna make a keep out zone. Because right now I can't see where my PCB pins are, because I had to have this piece of paper underneath this transparent rule. So I'm just gonna create a keep out area. Oh, that would be cool. Yeah, I definitely tune in to watch that, for sure. Alright, so let's create a new sketch. We can hide the first one. And now, first of all, I'm going to create a construction line by pressing X, R for rectangle, and I'm going to literally just provide like a keep out zone there that we're going to stay away from. So I'm thinking about doing an integrated wiring system so that it'll take all of the power wires, but also we want some mounts, because we've got two devices that are going to go in, one short term, one long term. So the short term device is going to be this Arduino Uno. So this is going to be the brains. This is going to be our controller for the CNC, right? It's got a Gerber firmware on it, which means we can control the stepper motors, the VFD. We got pretty much all of the controls. I'm not going to stick with this long term, because it's pretty much at its maximum and I can't really do much more than what we're doing. But to get the machine up and running, we're going to use the Uno as the controller. But what we're also going to use is a Raspberry Pi 4, and that's going to be the brains behind the project, so that we can run the CNC machine without a PC. So that's what we're going to use for the brains. You do it! Welcome into stream, buddy. Hope you're well. Keeping it real, right? Keeping it real. Covered terminal boxes are cheap on Amazon if you want high voltage terminal board. So literally, we're literally going to use some connector strip. Gonna use some connector strip. And we're gonna make a mounting system for all of this, right? So So let's crack on with the design. So I'm literally gonna loosely design this with some line tools. So first of all, we're gonna jump out of construction mode, and I'm going to place a line probably from here. Oh, we're still in construction mode. There we go. So let's go from about here. Go all the way up to this point here. There's going to be like an L shape. Here's another tip, right? Let me just zoom in on this so you can see this a bit better. With Fusion 360, if you touch a point, and then move away. See, you get that little square box around that point. Now when we pull down, you get like this dotted line. I don't know if you can make that out, but it allows you to find that as a reference point. And then we can come up and click that. So that's ultimately where our cable management system is going to go. We've got a minimal amount of room to come around here. Tuck in around. Shall we do that? Just thinking. High voltage, yeah, 230, 240 volts is the mains standard in the UK. The low voltage is going to be 12 and 24 volts, possibly even lower. It's going to be 5 volts as well for the control signals to the stepper drivers. So I think what I'm probably going to do... I think looking at the control box, I have got maybe 15, maybe 20 mil to tuck in around this area here. So I think what I might do is if I move this line, I'm just going to drag this down to here. We've got a bit of wiggle room at the top. Okay, and what I'm going to do is I'm going to... Am I going to segment this? I'll have to check how big this is, because I may be running into a bit of a problem here, but we'll see. So we want a line. Did I not confirm that? Was I just a buffoon and just not confirm? Yeah, I did that. Okay, so line. Loosely just bring that to here. Okay, I made some intentional errors here, so we're going to correct those. We'll hide the canvas. So we can now start to put some constraints on here. So if I make this a horizontal vertical line, that'll just snap it into place, which is good. I'm going to dimension the distance between these 2 points, which will make that 10 mil. Oh. Make sure you select the correct object. Okay, perfect. I'm going to trim that line out from there. But we now got this sort of rough shape that we're going to work on. So the drivers go in by here, and we're going to pretty much snap this into 3D space now, I think. So this is the rough shape of what we're going to make as our platform for mounting the boards, and how we're gonna kind of figure these things out. So let's make this 5 mil thick. 50? No, I don't think so. 5 mil. So you got 5 mil platform. So here's the cool thing. I took the liberty earlier on to bring in 2 files. I did a Google search for an Arduino Uno step file and also a Raspberry Pi 4 step file. One of the cool things you can do is you can actually bring those step files into Fusion 360 and then use them in your project. So I've got the Arduino and the Raspberry Pi here, and I can now get good reference points for where we're going to place some of these components. But secondly, we've also got some reference points for the fixing system. So let's go ahead and bring some of these. Let's bring this into this project. So all we do is I've gone into my library and I've grabbed the file and I'm just dragging and dropping them. So it's now going to tell me that designs inserted from another project will not be linked. Components from the selected design will be copied into this design. So we're copying that in. Where did I get it? I literally did a Google search. So I anticipated the Raspberry Pi question. I got it from GrabCAD. And it's given me a zip file. And it's got a bunch of different versions of the file. The guy's actually done like a photorealistic render of the unit. So they put in some time into this. So it's pretty cool. So I use GrabCAD. So what I can do now is I brought this in and I can rotate it. Right, and I can drag it around. I can bring it up. So instantly I can see a problem here. Scale seems off. That scale seems way off. I'm going to check my canvas scaling. Because if I put the Pi... Not the Pi, if I put the Uno in here... Yeah, there's something not right with that scaling. So let's check that out a moment. Calibrate. Turn off the bodies. So from here to here is 100 mil. It seems right. Let's double check. Let's double check. Right? No, it's always good to double check. So we've got 10 mil there. Well, there's your problem. I'm a complete buffoon. That's 200 mil, not 100. I am officially an idiot. Now that's more like it. Okay. So let's go into this sketch. Right, so we're going to move some things around now. Well, there's your problem. Know thyself, you do it. Know thyself. That's a superpower. If you're self-aware, right? If you are self-aware, that is one heck of a superpower. Right, so let's get this let's get this keep out zone set up, right? So that we don't encroach on the area for 5 mil, shall we? Well, I say it's a superpower. It can be a superpower, but it also can be a bit of a curse, because creators' curse is we're hypercritical of ourselves. So Alrighty, so there we go. Now I've just got to expand this a little bit. So I'm going to do that. I'm going to just scale it 200%. I just want it to be right. Alright, I'm going to put some more construction lines in. So we're just defining a few things here. Yeah, not quite perfectly straight. You can see what I'm talking about. So we're seeing an issue with perspective here. So we've got to allow a little bit of tolerance, right? Otherwise we're gonna fall foul. I'm just easing this a little bit just to give me a bit of breathing room. Yeah, exactly. The measurements were like half off, but well, that's not what I wanted. Do you see what happened there? So let me go full screen on that. So what happens here is when I dimension this, the construction line moved, not the line that we want to create on. So if I fix the construction line and now change it, let me get that. Cool. And again, I should have learnt my lesson, but I didn't. I'm going to fix that. We're going to dimension this and mill. Fix it. And then we'll dimension off there. Over constrain? How will I over constrain? There's no. Oh, I see what's going on. It's not perfectly parallel. Okay, let's make that parallel. There we go. Yeah, so if you've got a digital SLR camera with a zoom, then what you can do is to you can come all the way back, so you crush the depth perception, and then zoom in, and that will counter the perspective. What you're trying to do is make the rays of light that are being reflected from, well, that could be construction. You're trying to make those run parallel. Very much like stars in the night sky are considered parallel light beams, because the light is that far away, even though it is traveling in, there is an arc to it. It's imperceivable from the distances we're talking. So optically, it's parallel. Exactly, same here. I also use my phone, but it's about knowing the limitations of this method. I mean, if there are any engineers, mechanical, like machinists or anything like that, they're probably like wanting to punch the screen right now, because this isn't the tried and tested way of doing things. But that's the way I'm doing it, because I want to demonstrate that, you know, it is possible to do it this way and get a decent result. Come on, I want to fix that line. My mouse is being a bit of a butt tonight. All right. So we'll push this. Now, what do you think is going to happen? That's going to move, so I need to right-click that and fix it. Come on. Get out of dimension mode. Fix it. There we go. Now we can change that to 10 mil. So I'm giving myself a bit of, like, 10 mils worth of tolerance. I'm going to move these 3 lines in this direction. And now I'm going to dimension it around what I perceive is my... We're slightly in the keep out zone here, which is no biggie. You just warp it in GIMP afterwards. Yeah, you could do that, I suppose. Okay, so we're going to dimension this line from there. We're going to dimension these 2, they're 10 mils, so that should work out. Okay, that's probably what I want right there. So now when I finish, it's going to recalculate everything and bring that now back into play. So now I can hide the canvas. I can hide the sketches. Like so. And we've got this little plate that we're going to plonk down. There will be threads? What? I lost... I'm losing context of chat here. So, this one here. Learning curve will be threads? I'm sorry. I don't know what that reference is. This platform is ultimately what we're going to put in. This is going to be our cable management system. That's the plan. So, all right. So now let's bring in our Uno. Now that looks a lot better, right? So if I bring in the canvas, just to give us a representation of where this is going to go. Whoop, 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 come back here. Right, so we can select it. Yep. Context is still lost. Houston, we have meatloaf. Right, so we want to move the component. So it says faces. We'll change that to component. There we go. So I'm actually going to rotate this way. Because we're going to need... What? No! Okay, now we got it. Now we got it. I'm going to move this way, and I'm going to place it here because I want access to the outside world for the... Oh, fusion threads. Got to learn how to do threads in Fusion. I want to make my switch be tightened down on a bezel. So today I'm going to Google how to add threads to a cylinder. Oh! We did that last stream. And I can actually demonstrate that to you here if you so wish. Right, so I'm going to place that there with the intention of having a panel mount USB. So I'm gonna take some viewer Don't feel bad because this is what this stream is all about. I can show you pretty quickly, okay? So if I just quickly create a cylinder and let's have a look. Create a sketch. This is relevant, okay? So we'll create a circle. What size diameter thread you're gonna be making, Chris? Come on, this is all for you, man. What size diameter? I'm gonna say 18 mil, right? Just while we wait for you to give me the actual dimensions. You want a 19 mil cylinder. Oh, that wasn't a bad guess. I was close. 19 mil cylinder. Let's go. In fact, we're going to create a nut as well. You'll like this. Right, so to create a nut, what we're going to do is we're going to create a polygon. And we're going to do a circumscribed polygon. Right? And we're going to click it there. And we're putting in the radius. Right? So if we put in a... Let's say... Let's argument's sake. We're going to say a 30... So 15 mil radius. So it's a 30 mil diameter. Now we're going to put a center circle in here of 19 millimeters. Right? Here we go. Done. Finish sketch. That's all we need. So we're going to go extrude. We're going to extrude the nut by, I don't know, 12 mil, say? And we're going to extrude the cylinder by, let's say, I don't know, 50 mil. Okay, so there is our nut. And there is... Okay, that's cool. You can change this to your parameters that you need, but the concept of what we're talking about is the same. So what we're going to do is we're going to create threads on these objects. And in Fusion 360, this is sweet, right? I've never seen this so easy. So what we do is we go to create, we say thread, and we get this dialog box. Let's go full screen so you get the full effect, right? So we've got this dialog box, and the dialog box tells us what thread profile we're using, what size we're using, all of that cool stuff. First things first, we've got to select the face that we want to put the thread on. So let's put it on the cylinder first. Now let me just quickly zoom in on the cylinder. You'll notice that it looks a bit weird. And the reason it looks weird is because at the moment it's just a texture. It is not an actual thread. So to make this a real thread, you have to click I can't even speak. You have to click the modeled option. And when we click that, you'll see Fusion interpolate that into a physical sort of thread, right? So next then we choose our profile. So 18 mil, 19. We're on a 19 mil. Urgh. So there's no standard 19 mil. So is there something? ISO. Have we got anything in here that's going to give us 90 mil? Looks like it goes in 2 mil increments. Pipe threads. Oh my word. Hey Carol, welcome in. So what we'll do, we'll just go with, where were we? Metric profile. And we're going to go with an M20, just for the sake of moving through this reasonably quickly. Okay, so you can choose whether you have the threads full length or whether or not you only have them a certain distance. Right? So if we uncheck full length, we can use this to like pretty much say how much of the thread. We can create an offset. You can do some more like cool stuff, right? But for this purpose, we're gonna go full length, like so. Okay. We can choose whether we want a left or a right hand thread, and then once we've done that, we can click on OK, and that is our bar with the thread on it complete. All we've got to do now is to do the same for the nut. So we select the face first this time, go to create, and then choose threads. Make sure we choose modeled, and we want this 20 mil thread, right? I think that's what we selected, and click OK. So that's it, done. But there's a catch. Last stream we talked about clearance and tolerance. Right now, this is a zero clearance, zero tolerance thread. So right now, if you 3D printed these objects, wouldn't work. These would not fit together. So what you have to do is you have to, in fact, let me demonstrate why that's a problem. Let me bring that sketch back, and I'm going to create a new body. Right, and create new body. So click OK. We'll put the thread on here. Right, so if I do an inspection, so if I go inspect and sectional analysis, and I select this face here, and now I push this to the center of our object, we click OK. Let's have a look at these threads. Right, so these threads are... Oh, I'm not even on the right scene. I'm chatting away and I'm not on the right scene. What a complete... Yes, I got it. So you see that there's tiny gaps here, right? So the problem that we're going to have with this is that you'll never get these to mesh unless the only time that this will work is if you have a tap and die set, and you can cut the threads using a tap and die set, bringing them into tolerance. But most likely, you're going to want to take these off the printer and just screw them up, right? So how do we do that? Well, we have to build in some tolerance for the 3D printer. So to do that, we need 5 operations. It's going to take 5 operations to get this to be able to screw up straight off the bed. So let's do that. Let's turn the sectional analysis off a moment. And I'm going to turn off that nut, and we'll just turn on the screw if you like. Yeah, I mean that could be an option, right? If you're in a bind and you need something, for example, if you're interfacing with a mechanical fastener that already exists, right? So you've got an M10 bolt. You could print the tolerances in, but if it doesn't work, you can run an M10 tap or die on the object that's gonna interface with the other thing to bring it into tolerance. Which is not necessarily a bad idea, but depending on how strong the item is, you could end up actually breaking that item. And if it's that badly out of tolerance, you could even jam up your tap and die. Right, so how do we fix this? So we're going to modify the threads. So what we're going to do is we're going to select this top surface of the thread, the upper surface, and we're going to do a press pull of a distance of minus 0.2. Okay, like that. Boop. Done. That's the upper side. That's operation number 1. Operation number 2 is to do that on the underside. So we go press pull minus 0.2. So now we've got a 0.4 tolerance on the screw, right? So now we've got to do the same to the nut. So we come in here, choose the top surface, press pull, minus 0.2. Flip this upside down so we can see the underside face easy. Select that. Press pull. We do a minus 0.2. Okay, so that's operation number 4. Yeah, you'd probably end up with a fused part if you printed this all together. Right, so let's see what that's done. Now we've made those changes. What has that done to the thread? So we'll go back to our analysis. We'll have a look at the split view, and you can see, right, that we've got a lot more tolerance in the threads here. Now this looks like a massive gap. It really isn't. Trust me, it really isn't a massive gap. But one thing I can see is that we've come to a very sharp point on these threads. So this is going to wear out. This is going to damage if this is something that's going to be done up, undone, done up, undone over and over again. So we want to fix that. And to fix that, all we're going to do is we're going to come in and we're going to create a fillet. So we select the edge of the fillet. And now with the section analysis on, let's get in here and we'll say that we're going to give it, I don't know, 0.5. Let's see what that says. 0.5. What does that do? Oh, that looks horrible. Okay, 0.25. Better. 0.2. That'll do. Right, so we now don't have a really harsh, horrible thread to deal with. Now, depending on the layer height that you're actually going to print out, you know, it's you need to probably print at least 0.2 for this, for threads, to turn out reasonably well. Finer if you've got the time. So we click OK, and that's it. Done. We've now got a bolt and a nut that will 3D print. And when you take them off the bed, they might be a little bit tight to start with. And bearing in mind, the minus 0.2 is the setting I use for my printer. You might need to tweak it differently, more or less, on your printer. So a little bit of experimentation is needed. But ultimately, you should be able to 3D print those threads, no problem. What do you mean? Usual for ABS is around 0.12 or 0.15. Do you mean in terms of tolerance? So what I think you're talking about right there is the. Let's have a look. Yeah, so that you could. So what you're gotta be compensating for, and one is the inaccuracies in your 3D printer, which there is inaccuracies in every mechanical system. The question is how many zeros? Yeah, after the decimal point is it, or before, for that matter. But you're also looking at material shrinkage. Now, ABS does like to shrink, which is why you get the warping on layer 1, which is why you get cracking on tall print if you don't use a heated chamber. So that's what you're dealing with. But have a play around. I mean, I went with 0.2 with PETG, which has very little in the way of shrinkage from my understanding. The coefficient is a lot less than ABS, simply because it warps a lot less than ABS does. Yeah, it's what works for me out of the gates. So yeah, there you go. Hopefully that answered your question on threads. Okay, so let's get back to the control panel. Oh, responding to normal layer height. Cool. Okay, gotcha. That chat delay really kills context. Yep, I hope it does. I mean, so here is a part that I broke. Let's have a look what I got. Did I toss it at the very last minute? That's so unlike me. Ah, here it is. Right, so I've got a component that I 3D printed. And this is a tank fitting for a hydroponic system that I've built. And these are the threads. Custom threads, custom nut. And they came off the printer and worked out of the gate straight away. Right, so I was pretty dang pleased with that. Lost Algorithm, appreciate you, buddy. Speak to you soon. Be well. Whew. I gotta be fair, it is muggy and warm. We're due some thunderstorms, so hopefully we don't get problems with lightning knocking out the stream. That would suck. So how are you, Carol? I hope you're well. Right, so the next thing I've got to do in here is bring in our Raspberry Pi. So I'm just going to drag and drop the Raspberry Pi from my library. Yeah, chat delay. Yeah, chat delay is pretty... I mean, I'm on ultra low latency, so some of the chat delay you're seeing from me is ultimately me concentrating on what I'm doing. I think it's about 5 seconds or so worth of delay. Right, so let's get our Raspberry Pi in the approximate position. I'm going to can I go 15 mil? That'll do. It's only really to get approximate height details. Oh. I think we're going to place it somewhere in like this area. something like this, right? We've got to figure out how we're going to power it. Okay, so the cool thing about this now is that we can use these models in order to get our mounting points configured, right? So what we can do is when we activate our cable management system layer, what we can do is we put a sketch on the top surface here, like so. We'll capture the positions of things because we're moving stuff about. And then we're going to project. All right, we're going to project this hole here. This hole here. This hole here. This one there. And the same for the Arduino. The Arduino is more important because we were actually going to be mounting this in first, straight out the gates, right? So the Pi will be coming later. Right, we'll say okay to that. So now I can hide these objects. Like so. And I've now got the mounting holes where I need them to be. Yeah. Well, we got amber warnings for flooding and for thunderstorms. I mean, it's a glorious day. So yeah, of course we've got a warning for thunderstorms and rain because this is UK and this is Wales. So what can I say? Right, okay. So now let's get rid of our canvas. I don't want to see that anymore. And we're gonna put in place our. Gonna create these holes. Do I want to create holes? Tell you what I'm gonna do. I'm actually gonna do an offset. No, I'm not. I am gonna put the holes through here. So I'm gonna put name this holes. I'm gonna try and take my own advice and name things. All right, so what I'm going to do now is I'm going to extrude. I'm going to select each one of these holes. Like so. And select them all. And again, what we're going to do is we're going to flip this over and we're going to change the parameters for the extrude. We're going to say the extent type, we're going to go to object. And that means we can set something in 3D space that it's going to extrude the these holes out to, so that if we change the thickness, it'll be representational of the gap, right? So we'll select the bottom side. Now we can change the thickness of this object, but these holes are always going to be punched all the way through, right? So we may need to change the thickness. All right, so I'm going to try an experiment here. So I want to run a cable from the power supply, from this power supply over to the input jack, right? So what we're going to do is we're going to create two sketches. These sketches are effectively going to be used to cut a channel through the plastic to give it like a trace of the wire. Is it going to work? I don't know. Let's find out, shall we? So let's go with the ground wire first. I don't know why. I'm just going to choose the ground wire. I'm probably going to have to punch this over a little bit, actually, looking at that. So if I go back into the base and change that to 5 mil. I'm edging my bets here. I'm encroaching on the keep out a little bit, but I'm gonna risk it. Risk it for a biscuit. Right, so what we're gonna do is we're going to put a construction plane on the face of this edge. And then what we're gonna do is we're going to create a sketch on that face. And this is going to be representational of the wire. Okay, so let's say the wire's got a 2. Well, actually, let's measure it. I'm gonna use my digital calipers, and I'm going to measure it. Oh boy, it does feel muggy, like it's going to give us some thunder and lightning. Right, so 2.8 mil. We're going to go 3. I'm going to go 3 mil. Right, let's go 3 mil. So we want it approximately here. Like that. Go 3 mil. Like that. And now we'll move it so that it actually breaks through the surface. Now, Chris, this might be something you're interested in. So keep watching. So what I'm gonna attempt to do is create a channel in the base that we're gonna actually embed the wire into. All right. So we're gonna finish that sketch. We've got a single sketch right there. So now I want to create a new sketch on the surface here. And I'm going to project the center of this circle like so. I actually want the center, so come on. Yeah, right? So I'm hopefully going to create like a comb that's going to train the wire. That's the plan, right? That's what we're aiming for. So I'm going to create a line now. This is going to represent the wire path. So we're going to loosely draw the wire path. In fact, probably want to go a bit more. Take it to there, right? Okay. Let me see. Okay. Line. Okay, so you'll probably realize that this is an absolutely horrible path, right? Because there's right angles. So we're going to fillet the line to just create a nicer sort of turn. And we're going to do that with each of the lines. So we've got a 5 mil radius on there, so it's not too sharp. Like so, and then we finish the sketch. So I'm going to hide the canvas so you guys can see exactly what I'm doing, and I'm also going to bring this up full screen. Yeah, could do that also. So you don't see any cabling at all. Right, so what we've got is we've got a profile of the wire in the circle, and we have a path that we want to run the wire along. And this is a horrible path. I'm going to have to tweak this. But anyway, that's by the way. So what we're going to do is we're going to create... well, no, we're not, because we're still in the sketch mode. So we'll quit the sketch mode. We're going to go create, and we're going to create a sweep. Now, the cool thing about sweeps is you can use polylines as the path, as well as regular lines. But because we're in a 2D plane, so the polyline will allow you to do a 3-dimensional sweep, where all we want to do is a 2D sweep. So what we're going to do is we're going to select our profile, which is that one. And then we're going to select our path, and watch this. Boom. We now have a channel that our wire can be pressed into, potentially friction fit along to where we want it to pop out. Right? So now, let's say, for example, we want to do like live earth neutral. Right? It's cool. So we're going to go back into... I don't know why we've got all of these. My timeline has just exploded. It shouldn't have, but it has. Never mind. I'm not going to worry too much for tonight. Right, where was I? Right, so let's create... Let's create 2 other paths that we're going to sweep for the the high voltage, live, neutral, and earth. So let's do that. So we'll go into this sketch. We'll edit this one. In fact, no. We want to edit. Let's edit this one first. And we'll need to bring our canvas back, because I need to know where the connections are. So I've created a construction line to show where the center of the circle is, and now we're going to make that a coincident. So we click the center of the circle, click that, and it just jumps up onto the line. All we need to do now is dimension the circles, and we'll say 8 mil between them. Just for consistency's sake. That's actually not that bad. That looks pretty good. Okay, so we can finish that sketch. And now when we go into the second sketch, we can like profile out, edit sketch. So first of all, we gotta punch this line in. So we want to move this line this way. Like so. And if we now just rotate here, show me the other sketch. We're going to project the other centers like so, and now we go back to the top, we rotate this round, and now if I do, oh, I wonder, I could do an offset here, right? Because we said they were 8 mils. So if I go O for offset, we want to chain the selection and say 8 mil. Boom. Now I can't make an offset of an offset, but I need to make an offset of the primary line. So we'll do another offset. This time we'll say 16 mil. And we should have some wires here. Although they do can I dimension these? Or will it over constrain? It already has a reference for this geometry. Yeah, thanks. Interesting. It didn't give me a radius on this offset. Ooh. Ooh. Right, so let's delete the offsets. Because then we can kind of play. There we go. The offsets are now deleted. So I can say dimension that with that. And we'll say that's 4 mil. That gives us a millimeter in between. Dimension that one with that one. We'll make that 4 mil again. Okay, now we're going to move that lot up there. Right. And now we need to fillet the line where it didn't fillet before. And we said 5 mil. And we'll do the same for all of the fillets that didn't work. That's either end of the trough. Right. Yep, absolutely. We can absolutely do that. So when I finish the sketch now, okay, let's see if I can edit this sweep. So edit the feature. It didn't like it because we've changed some things, right? So should be able to recalculate that. So profile 1 selected, path 1 selected, chain selection. Okay, let's get rid of you. Profile. For some reason it didn't like it. Huh? Why is it not working now? Okay, so we'll delete that there and we'll try again. So we'll create a sweep. There's something about this area here that it doesn't like. Not quite sure what that is. That's strange. Very strange. So we can figure this out. If I edit this sketch, I'm going to trim this section here, right? Just get rid of it. So I think that's a radius for one of these other lines. So I'm going to trim all of these lines. Okay, so we'll put new lines in here. Boop. That's what I love about this, is you can kind of... You can play around with it until it works. I mean, if it's your day job, you probably don't want to do that. But, I mean, this isn't my day job. So, this is my hobby. Alright, so let's now fillet the lines. I'll do a 5mm fillet. And there. Okay, this isn't perfect, right? So this is unlikely to be our final version. But that should be what we're after here. Nice! Good luck, buddy. Happy printing. Okay, so we now finish the sketch. We'll get rid of that sweep because the geometry is completely changed. And we shall create a sweep. There we go. Oh, we've gone through a component here. We've gone through a hole. Well, that's not good. I didn't spot that at the time. So we'll edit the sketch. We're going to move this wire. Right, let's move all of them. This has become I'm fixing my drawing sketch stream. Okay, let's quickly fillet these lines and we'll be done with this. Hopefully. So dragging these over, it didn't like it, and it changed the parameters of the sweep, which might have been what caused the problem further on down here, right? Okay. Yeah, there is always one more thing. That's what you call scope creep. For sure. Right, okay, so let's create this sweep. Let's get this done. All right, so we'll do that. We'll create another sweep. And then we'll create a final sweep. Not that I like running high voltage underneath an Arduino Uno. That's probably like a bad idea, but I'm doing this predominantly to demonstrate the means to an end, if you like. So we've now got these channels. We've now got these channels for the wires to run through. Yep. It has ways of doing that to you. Yeah, that'd probably be a good idea, actually. That makes a lot of sense. That does make a lot of sense. And the cool thing is that we can change that in one simple sketch. So this is the top surface, right? If I go back to the original sketch for the circles, right? So they're there. if I just right click and unfix that, dimension this, I think it's going to be like, oh, let's project that top line, project that top line like so. Okay, dimension. What is that? 0.6, 0.8, what is it? 0.8. Right, okay, cool. So if I dimension, oh sorry, I project the bottom line like that, delete that dimension. And then we dimension from there to there and say that's 0.8. Down they go. When I click finish, our wires are now planted on the underside. As easy as that. As easy as that. That's pretty slick, right? So, you might be wondering, how on earth am I going to attach this plate into the system? Right? And that would be an extremely good question. And the answer to that is, with a little bit of cleverness, smug, to say the least. If I go ahead and export this, and click OK, and we'll call this base. Oh, caps lock on. Base V1. Right? And let's open hot glue. No. Can you use Prusa Slicer? Now, here's a cool thing, right? I love this. I've used this a number of times now, and I absolutely love this feature. And most slicers will do this. I did this in Simplify 3D. I'm currently using Prusa Slicer. So let's add that, and we'll go to Documents. We'll go to CNC. We'll go to Live, and we'll go to Base. Bring the base in. Oh, it just fits on my bed. Look at that. Liking that. That's gonna work. Okay. So here is how we're gonna do this. When we go into the print settings and we go into the layer height, we have options for solid layers. I generally run around 4 top layers because of wanting to make sure the surface quality on the top is top notch, right? So bottom layers, I'm actually gonna say none. Okay, and then when we go to infill, I'm going to put this to a reasonably high percentage. I'm going to go for, I don't know, let's go 60%. Let's see what that looks like. So when we go here, we'll slice now. Toolpath. Okay, so it doesn't like the fact that we've got this perimeter being printed. That's why I like that. It's turned red. It's very, very clear that something's not wrong. So let's fix that. Skirt and brim. Loops minimum. None. Okay, so now let's reslice. That should fix that problem. Yes, should do. Should do. Right, so what we've got now, if I just bring this down to show us the infill, I want to see the infill pattern. So that's quite a coarse infill pattern, right? Sorry, quite fine. Probably a little bit too fine. So let's go infill. Let's go 45. And what I'm doing is I'm going to pepper pot the bottom side of the print with these little holes because I have no bottom layers. It's all infill, right? These can all be used as holes for screws. It's just about catching the right one, making them the right size. Waffles! You look away, buddy. Good to see you. Welcome in. So when I bring this down, we'll see that we've got our channel. So there's our channels for the wires. And it's only until we complete now, I wonder if we can do varying infill. Okay, let's have a look. Print settings. Combine infill every so many layers. So only where needed. Let's see what that does. Okay, it's not done anything there, right? So I think what I'll do, what layer are we on? That's layer 11, layer 12. So if I go in here and say infill, combine every 12 layers, it's going to print I was expecting it to bridge. But it didn't. But that should be okay. I'm reasonably okay with that. Whoop. Yeah, I think we should be good. As long as we don't poke a screw through it. Now that would be bad, poking a screw through it. Now, one thing I could do here to make this a little bit sort of easier on wiring is to make this a little bit thicker so that we've got room to run the low voltage wires on the top. But I like the idea. I like the concept of separating the wires. High voltage on the bottom, low voltage on the top. A little bit like a multi-layer PCB, right? I'm definitely going to have to put an offset on the Arduino because I think these holes are going to be too big to take the PCB standoffs I'm going to be using. But I'm pretty happy with how this concept is shaping up. It's going to give me the room that I need for bits and pieces. Yeah, true enough. True enough. I mean, it's running right underneath an Arduino, so I might have to, I might have to work on that. I mean, if I make it thicker, potentially I might make it so that instead of 3 channels, I actually have 1, but it's slightly larger to accommodate the wires. And we use zip ties to, we'll put some strategically placed strip zip tie holes so that we can get a loop in there. Yeah, so the Pi's not... There's going to be a high voltage rail just coming in through here because the switch is by here anyway. So I think we'll be all right. But I like the way this is shaping up. So one of the things I got to do is figure out how we're going to connect the wires from each of the individual driver boards to the Arduino. I might need to make a custom circuit board in order to just port things in. Maybe like a hat that will feed everything through. And all I've got is like just some header pins that we just plug into. That would be cool. I don't know if I've got any copper clad board here though. I might need to order some in. But I think that could very well be the way forward. It's getting dark now. That's good. That tells us it's getting late. So do we have any questions from chat based upon what we've covered tonight? And if not, do we have any questions in chat in general that you want me to take a look at as we look to close out the remainder of what we have for stream? I like that. I think it's pretty snazzy. So as I said at the beginning of the stream, we've got a CNC machine we are restoring. This is the said machine. I keep going to the wrong scene. Why do I do that? Because I'm an idiot, that's why. So it's a 600 by 400 work area. It has a water-cooled spindle. Got a water-cooled spindle. It's a 1500 watt water-cooled spindle. I do have to get a VFD for this. To be able to drive it, so I'm tempted about. I've got a palm router, so to get me up and running until I can afford a VFD, I'm potentially gonna make another bracket for this to mount the router instead. That could be a workable option just to get me up and running short term. But ideally, I want to be running the spindle because the spindle is going to be a lot quieter. So the unit came with the water cooler, which is this white box here. And this is the control box we've been working on tonight. Oh, well, hey, I mean, you're talking to the master of jumping into projects not knowing where to start, right? I mean, that's where we that's how we got to Cheap Deck, right? Cheap Deck is as I say, my stream controller, and I got to program. I learned how to program a multi-threaded application. I don't know, programmer. I'm a hack, and the fact that I got it working through a secure TLS secured MQTT broker on my Raspberry Pi over here, that's pretty significant, right? And I gotta be fair, I didn't do it alone. I had a significant amount of help, but I got there. It's pretty cool. Right? Exactly. Exactly. I mean, it's not insignificant. I mean, that I struggle to pick this unit up. Yeah, I mean, so for full disclosure, okay, the iCube Workshop is a documentary style channel. It's documenting my journey, learning how to do things, teaching myself. I have YouTube. I mean, I've got the internet, so I'm going to use that as a resource. But I'm self-taught, and I use an iterative process. Well, actually, I've got a two-phase approach. My first phase is breaking things down. So I see a finished product, and then I break it down into the component parts within it. I may not understand exactly how they work, but in terms of like a block diagram, like a Visio diagram, you've got a display unit, you've got the processor, which has the programming on it, you've got the keypad, you know, those sorts of blocks. Now, there's also a third element to it, which is around safety. So, for example, I taught myself how to weld because I had a requirement a few years back to make biodiesel. So I taught myself how to make biodiesel. So before I got there, I taught myself how to weld, also how to sweat copper pipes to make all the plumbing for the processing unit. And then I went on then to actually learn how to convert waste vegetable oil into biodiesel. And it's not just thinning it down, you're actually creating a chemical reaction that it actually changes its state. And there's like risk factors because you've got chemicals you're using that are particularly not compatible to life. So you have to be cognizant of your risks in those areas and either plan them out so they no longer become risks, or you mitigate risks. So one of the risks I had was being splashed by what's known by the catalyst and one of the components that create the reaction, known as sodium methoxide. And there was no getting away from this splash risk. So I had to mitigate it by making sure I had a wash station so I could just like wash out the active elements. Carol, thank you so much. I appreciate you hanging out in chat. You have a great night. We will speak soon. Take care. Yeah, right? So it's risk factors, right? So that was just an example. So once I've broken it down, I then go through an iterative process of figuring out, okay, so a device needs to connect to the internet or connect to my network. How do I do that? So I do research on how to connect an Arduino to my network. Okay, I've got it connected to my network. Now I need it to talk to... Now I need it to talk to an MQTT broker. Well, I don't have one of those. I better set up an MQTT broker. So I figure out how to do that. Now I've got the MQTT broker, I got to figure out how to make it talk to it. So I do my research and literally step by step by step by step until I get to the end. And then I look back at my code and say, okay, time to clean that up. So I might go through maybe 2 or 3 passes where I'll write functions, because I've gained more understanding, and just rinse and repeat. And over the iterations, I will refine that process. Yeah, absolutely. I'm what's so there's different types of learning styles, and I learned very early on. I'm what's known as a kinesthetic, meaning that I learn by doing. I can read a book, and some of it goes in. I kind of get it. If somebody lectures me, I probably fall asleep. But if you put something in front of me and give me the tools and say crack on, I'm there, right? That's my jam. So. Yep, 2 hours of development, 20 hours of debugging. Yeah, and then probably another, 60 hours of commenting just in case somebody's got to come behind you and try and unravel the noodle soup that you have created. So, and literally, I mean, that is ultimately how I created Cheap Deck. And as I say, Cheap Deck is a multi-threaded application. It runs on both cores of the ESP32. One core deals with the display. The other core deals with the main program processing of communications and stuff like that. And that's like, you know, for me, that's top drawer. I'm really pleased with that. For somebody who's a complete hack, by his own admission, I'm pretty stoked with the end result of that. Yeah, I've not delved into the creation of libraries per se. I mean, I've written functions and stuffed them into like different locations, but that's not the same as a library, I know, but that's probably on my agenda to do at some point, but we'll see. Right then, it is now 10 p.m. UK time. I'm going to close out stream very shortly. So first of all, I'd like to thank everybody for hanging out in chat. Appreciate you all. I am going to be live streaming again on YouTube at 8 p.m. till 10 p.m. next Wednesday. And we will be probably progressing the CNC control box. Hopefully I'll have printed out the board and we'll be installing it and starting to figure out the wires and getting everything hooked up the way it needs to be. Yeah, right? Down to under 100 lines. Nice. Love it. That's pretty cool. So, unless there's any questions that are absolutely imperative to answer right now, I'm going to wrap stream. Appreciate everyone hanging out. I will be back on Wednesday next week. Let's see if this works. Alexa, turn on end. Ooh, is he going to do it?
End isn't responding.
Yeah!
Check its network connection and power supply.
Didn't respond within the time, but it did it. It did it. Right, guys. I got some voice controls to chat for yeah, right. Alexa, turn main on. Right?
Okay.
Tell me about it. Talk about I mean, while Cheap Deck's not on my arm, right? Everyone's Alexa just got confused. Love it. Alexa, turn on overhead. Yeah, I know, right? Woo!
Okay.
Alexa, turn on main.
Okay.
That's pretty slick, right? But I could probably talk about that maybe on the Twitch stream. I don't know. We'll see. We'll see. Right then, guys. Have fun. Be safe. Make something cool. And I will catch you in the next stream. Alexa, turn mic off.